Well, hello there everybody, this is ATrueNerd here, and we are continuing our series on how to build a little robot. Now what I have in front of me are a couple of boards. These are both Arduino clones. This one's from Olimex, this is an industrial guy. It has a battery charger built in. It's not a bad little guy, it's a pretty handy little unit. It is a little bit has a little bit better protection from static discharge, things like that. It has more holes in it, things like, you know, nothing too crazy. This is another clone of a standard Arduino Uno. But these are probably, this style is probably something that you would consider using for your robot. But I'm going to go through a few of them, and I'm going to say, you know, just kind of talk about, well, state what I know about them offhand, and we'll go through a few. And yeah, here we go. Okay, this is one of my favorites. This is the Arduino Mega 2560. It has the let's see here. Yeah, the AT Mega 2560. Runs at 16 megahertz. I believe it has 256K of program memory, something like 32K of RAM, and it's a pretty nice little unit that's got lots of I/O. Has functions at 5 volts, which is nice. Aside from that, I mean, there's not too many ways you can go wrong. You can buy these either, you know, as a clone, or you can buy them, you know, for about $11, or you can buy them. I don't know if you can buy them still from Arduino, but or Genuino as they call them now. This is one of my favorites if you don't have a lot of space, like if you're not worried too much about space. Like I said, 5 volts, nice, supported by Arduino, well, in terms of the compiler anyways, and it's straightforward, easy to use, and can't really complain about that. Okay, this one is your typical Arduino Nano. This one here is a clone. You can buy these for about $3, and they are, you know, they do not use the FTDI chips. They use, I believe, a CH1340G, and they do work. They do work reasonably well. Some I've had to have few that have been a little bit spotty on transferring over, but what you do, test them first before you start building around them. And I mean, for the price of 10 of these, you can get one of these from Arduino. I mean, they charge way too much for these anyways, and I'm not even sure that they even support them anymore or sell them. So this one here is a Funduino or whatever, but it is this one does contain an FTDI chip for communication over RS-232. And here we have our Arduino Do. They don't support, well, they don't really sell these anymore. Apparently they didn't, you know, they didn't really sell very well, and they're not a bad little chip on them. They're reasonably fast. It's a 3.3 volt. I believe they operate at something like 60 megahertz. I mean, they are fast. They're pretty zippy. You can serve as a USB host. Yeah, but other than that, I mean, it's they're pretty straightforward. You can program them just the same way as anything else, but again, they are 3.3 volts, so interfacing can be difficult. So you may have to run level shifters between everything. So if you're doing any kind of serial or anything like that, level shifters are required. I do not believe there are very many 5 volt tolerant pins on this. There may be a couple, but I don't recall if there being that many. So that is a serious consideration. You get some real juice out of it. It's an ARM processor, but it is limited in the fact that it is that it runs at 3.3 volts. But most fast stuff does. Something to consider. Now this little puppy here is a really neat little unit. This one can This one is its own Wi-Fi module and microcontroller. Typically, they are called a node MCU, and it's actually the ESP8266, but they are really neat unit. Typically speaking, the units that you purchase off eBay or whatever, they will come with a Lua script interpreter, but you can put MicroPython on it, and it is not just like a watered down Python. It is a full Python implementation, and it will run on this, and it's you can tie into Wi-Fi, you can send data back and forth, you can, I mean, the possibilities on these things are not limitless, but impressive. You do have some shortcomings. There's not much in the way of analog to digital, and not much I/O, things like that. I2C, I don't think you have access to certain things. You don't have access to certain things, but overall, I mean, you could make little workarounds or have another microcontroller handle certain things while this one handles, your more how would I say, robust tasks. This here is a BeagleBone. Let me just see here. Yeah, it runs a Texas Instruments ARM chip. This is the original revision. There is a BeagleBone Black. It runs at, I believe, 400 megahertz, and it's designed to fit inside of a Altoids tin. It does, I guess, but besides that, you can store stuff on an SD card. You can tie into your computer with it. It's got a great deal of computational ability. Has quite a bit of I/O. The only thing is that when using these kinds of devices, is you have to remember you're generally running Linux, and handling I/O is not that fast. So you have a granularity you have to deal with when you're dealing with I/O. Sometimes it's best to have I/O be handled by even a small microcontroller or something to that effect, rather than this, and then just communicate. You can communicate with these straight up serially, and have the two communicate with each other and transfer information that way. But these are, they are well supported. They're, people use them all the time for all kinds of applications. Worth looking at. It is kind of an advanced user type thing, but hey, give it a shot if you like. I just thought I'd show this guy off here. This is a full through-hole component Arduino with a 9-pin header and everything. So it's a kind of interesting little dealie. You would have to run an RS-232 converter for this, and then it has the Max 232 chip on it. I don't think there are any no surface mount components whatsoever. It's all through hole. Interesting. Here are some unusual ones. These are Netduinos. Here, I'll put this the right way, and this one the right way. They can both be programmed directly from the computer, and you use Microsoft Visual Studio. You can program in C#, I believe Visual Basic, but I think they prefer using C#. Problem is, once you program them, the underlying library is so large that you have very little program room left. So, I mean, these are an idea, but I wouldn't recommend them. And they make newer versions, I believe, that are a little bit more voluptuous with their memory. So, a little bit more generous. So, this is a consideration, but not much of one. I just figured I'd show these guys off. Here are a couple of semi-random ones. This one is a chip kit made by Digilent, and it uses the microchip 32-bit processors. The Their support has gotten better over the years. I've noticed that you can use the actual Arduino IDE, stuff like that, and it compiles reasonably well, as far as I know. This one does exactly the same thing. However, this is called a Pinguino. Runs a 32-bit microchip processors, microcontroller. I don't know the stats. You'd have to look them up, but they this is a good option as well. But the support is really lacking. You have to remember that this is an old Emacs built one, but it is Pinguino, and they're interesting, but they're the nice form factor, nice and small. So if that's a consideration, that might be something you want to look into. Okay, what I have here is an interesting little creature. It probably isn't that useful for a robot, but I figured I'd show it anyways because I don't think these things get enough attention. This is a fully functioning little computer. You can plug in a USB port, stuff like that. It's not quite like a Raspberry Pi. Kind of like a predecessor, I would say. And it runs its own proprietary version of BASIC. So when you have it plugged in, up comes the BASIC prompt. You can run BASIC programs. The SD card stores everything, and you're off and running. I've used this before as a basic in I/O kind of like just for collecting data, things like that. I mean, it's convenient to use because you can just simply plug it in and it works. And aside from that, I guess that's all you can really ask. And this is the color version of that device. It obviously doesn't fit in the case like that or anything, but it's quite it's good for prototyping. If you have a big robot, I guess I don't see why you wouldn't use it. You can also, one thing I should mention is it runs the 32-bit microchip processor, and like I said, it has its own interpreter built in. So basic interpreter handles all the I/O coming in and out. You can run a composite monitor, so you can run one of those little back screen monitors or whatever, like back view, rear view monitors. Very handy in that regard. But I would never really expect anyone to use this for any good reason. And here we have a Raspberry Pi Zero. You can see all the cables going into it. I'm not going to take them out because it's a bit of a pain. Actually, why not? Let's take them out. I'll leave that in there. Very small form factor, does not come with this case. You obviously can put an SD card on it. You can run a USB hub. You can run Wi-Fi. Extremely powerful for its size. Remarkable. And the operating system is supported by the Raspberry Pi Foundation. And you can put cameras, you can put, like this band here's camera port. You can run a composite monitor, so just like I was saying before, you can run one of those little TVs that for rear view screen. Obviously HDMI output for a more robust one. You have USB out or USB host and USB power. I don't like that too much. I wish there were, well, there is a way to do it, but I wish it were a little bit more direct, maybe a header or something that took 5-volt power. But, all in all, it's for effectively, I'd say with it shipped, we're talking about $12 Canadian. So, you cannot beat this. Not with a stick, not with anything. And it has a pretty fast UART on it. You can bump it up to a fair amount. So you can program this thing in almost anything you want. I mean, you can program it in C. You could, if you so desired. You can program it in Python, which is probably the preferred way. Graphics wise, I was surprised. I would say it runs like a 233 megahertz Pentium. Like when I used to do graphical like game programming back in the day, I would say it was about like that. So I mean, it's well worth looking at. Like, you have a little display on your robot. Don't count on the timing on the pins, but there is I/O there. Very interesting device indeed. And finally, but not last, or not last but not least, your basic MCUs. So I mean, they come from a variety of manufacturers. A lot of times, especially for example, Microchip, they give away the compiler for free. I mean, optimization is what you pay for. This is an STC, but let's say Atmel, you can get a free tool chain. You can get a compiler for that too. Some of the other ones are not so forgiving. I don't believe the Texas Instruments compiler is free. I think up to a certain amount of code it is. Some of the more rare ones, like well, not rare, but industrial ones like Motorola, I wouldn't count on having free tools. But there are, there's lots of tool chains out there, lots of different microcontrollers, lots of different ways to control a robot. Hell, if you were really, if you're feeling zesty, try controlling it from a remote computer. I mean, you can do that too. But ultimately, I'm going to go with a simple one this time around. I am going to go with my hunky-dory little Arduino Nano. Well, I might change my mind by the time I get to that point, but chances are it'll be either my Arduino Nano or an Arduino Mega. Don't know, don't care, doesn't matter at this point. It really depends on what we want this guy to do and what we're going to put on her. Anyways, this has been ATrueNerd here, and we've just been discussing the microcontrollers we might use on such a robot. You guys have a good day, night, or whatever it happens to be. Remember to keep on building. Good night.